I'm Madonna, welcome to Gathering Folds, and today we're going to be talking about folding triangle grids on square sheets of paper and this Miura-Ori corrugation that's really fun to play with and has a lot of great engineering properties too. Now I'm going to be doing a little bit less repeats of this in the video, but the principle is the same and you can apply it to whatever size of grid you like. So let's get started with that triangle grid on a square. I'm going to take my bottom edge and fold it up to the top edge, but instead of folding all the way through, I'm going to pinch on the right and on the left. So I'm making these pinches halfway along the right and left edges of the paper. And now when I open up, I'm going to bring that bottom edge to those pinch marks and again make another pinch, this time in the middle. So I want the middle about third of the paper and pinch that. And then I'm going to rotate the paper halfway around so that that quarter pinch is now in the top half of the paper. And I'm going to bring my bottom left corner, pivoting on the half pinch and bringing the corner to the quarter pinch and folding all the way through. So by bringing this half of the length of the edge of the paper up to the quarter pinch, what I've got is a quarter, a half, some other measure, and this is a right triangle. So effectively we have a special right triangle of 1, 2, and then that third edge is going to be square root of 3. So this angle here is 60 degrees, which means that this angle on top here is also 60 degrees because it's folding the remaining space of the 180 in half. So if that's 60, then that is 60 and that is 60 as well. So we're going to do that on the other side of the paper, bringing the bottom right corner up, pivoting on the half pinch, going up to the quarter pinch, bringing that corner to the quarter pinch, and whenever you need to remember this in the wild, remember that you're doing a special right triangle where we have 1 and 2. So 1 for the short edge of our special triangle and 2 for the longest edge. Opening up, I'm going to rotate halfway around so those diagonals are now in the top half of the paper. And I'm going to bring my new bottom left edge up so that the bottom half of the left edge of the paper is now laying along this diagonal fold, folding the angle in half. So now we really do have 60, 60, 60 degree angles for these three angles. And then the same with the bottom right as well. So I'm bringing the bottom half of the right edge to meet that diagonal fold in the top half of the paper and folding all the way through. Now, because we're folding a grid, I like to reverse all of my creases so that they're neutral. So I'm going to flip the paper over, and on this side of the paper, all of those folds were done as mountains. I'm going to take them each one at a time and turn them into valley folds. And then I'm going to flip the paper back over so we're on our original side. And I'm going to rotate a quarter turn. So now these crossed diagonals are on the left and right halves instead of the top and bottom halves. And I'm going to bring the bottom edge of my paper to the top And if you're already familiar with folding triangle grids or grids in general, I'm going for 8 divisions total. And now we see the full equilateral triangles on our paper. Now, on these left and right edges, the ends of the triangles are kind of going off the paper, and that's to be expected because the equilateral triangle is based off of like a 2 to square root of 3 ratio, and our square is 1 to 1. So we're not going to have all the sides of our paper having corners of these triangles. So in order to get the next round of divisions, I'm going to do 2 more divisions of 2. So we've already divided the paper in half, and I'm going for 8 total divisions. So next up I need quarters. So I'm bringing the top and bottom sides of my paper into the center. And I like to do it by folding away from me. So after I've brought the bottom edge up, I'm going to rotate halfway around and bring the new bottom edge up to the middle. And open. Flipping over, I'm going to reverse these new creases, and I'm going to catch up in the diagonal direction before doing the final division of 2. So now I'm going to pick a diagonal direction, make those folds horizontal relative to me. And I'm seeing good discussion in the chat about corrugations, and they are indeed fun because you can get that nice squishiness of the corrugation. They're also, they tend to be a little bit faster to fold than my typical tessellations. And they have some really interesting engineering applications that we'll get into in a bit. So this time I folded an existing diagonal fold to the next one, and there's this corner sticking out, and I have some folds that I can use to reference it, but I'm going to wait until I have a better reference to fold those new grid lines in the corners. So I'm going to flip over and reverse my new crease, then flip back to the valley side of my gridding and pick the other diagonal direction, bring those 2 grid lines together. And this time, when we have that triangle sticking out further, I have a fold here that I can align the edge of my paper with. And so it doesn't matter if I've stayed folded and I'm bringing that up, or if I open out and I bring that edge of the paper up to meet this existing fold. And I also want to check that these folds in here are lining up above and below my flap. And that's something that I'm doing visually, but I'm emphasizing by folding it so you can see it better on video. And then rotating halfway around, we'll do the same thing with the opposite corner. So I've got that fold line, that's the one that went through the center in the other diagonal direction, that I can fold the edge of my paper to. And I'm making sure that the folds in here are lining up as well. And flipping over, I'll reverse all 3 of my new creases. And one of the things that I've noticed when I teach grids in person is that some people don't emphasize the fold lines hard enough, and then it's really hard to fold other things with it if those folds aren't really strongly creased. So I've returned to the first diagonal direction to get those bits in the corner now that we have that grid line going straight to the edge that I can align my edge of the paper with. So one of the tools I use to get my creases nice and strong is this bone folder. And I've been using the same bone folder for about 5 years now. And there's very little wear on it. And it's one of the things that is included in the paper packs that I sell on my website at gatheringfolds.com. So having, so one of the questions that I always get when folding tessellations is, what paper do you use? And this paper is Skytone. But before I go deeper into that, I'll get you started on the next set of repeats. So while I'm in this diagonal direction, I may as well stay there. I'm going to do one more division of 2. I'm going to bring this grid line that we just folded up to the next existing grid line. And this is kind of where we need to remember that only 2 edges of the paper have corners of triangles on the edge of the paper. Those other edges don't have the corners of triangles on them. So when we see this fold coming to the corner of the triangle, that's not something that we can stably rely on. It's just a coincidence that it happens to come pretty close. And once again, we have a little corner sticking out. For today's purposes, since this is our last grid division, I'm going to fold that up using my fold underneath as the reference. But if I was going for more divisions, I would wait until I have that other diagonal direction and have a better reference to fold to. And so I'm going to fold every space between parallel grid lines in half. I'm going to work through one direction and then reverse those new creases and switch to another direction. And back to the Skytone paper and the tools that I use. Skytone is one of those just really wonderful papers for all kinds of tessellations, corrugations, and flat foldable tessellations, like the ones that I usually teach. And it's a bit lighter than something like elephant hide, which is more of a well-known standard origami paper. And so being lighter means that it doesn't take as much hand strength to crease it all the way. Like if you fold a lot, you'll really notice a difference in hand fatigue with different papers. And so Skytone is that nice middle ground between like an elephant hide and a kami, for example. And so that is what I recommend for all of my students. Taunt is another good choice for corrugations, especially for, well, I'm going to say especially for corrugations, elephant hide, like going with a thicker paper, is useful because you will be having multiple states. Like it's going to be a movable, continuously folding thing where you're not necessarily popping vertices back and forth all the time, but it is going to have a little bit more wear and tear than other tessellations that reach a final state and then stay there. And then another resource that I have available, so I guess some context on why I sell Skytone, is that it's really, in the origami world, it's really just available straight from the manufacturer. And they don't generally have a lot of colors available at a time. So I've accumulated a bit of a hoard. And so you don't need to deal with the manufacturer's website. You don't need to deal with figuring out which of the 4 weights you want to order. You can get multiple colors at a time instead of buying a single color by the sheet. So those are all reasons why I make Skytone available through my own site. And then another resource that's helpful as you get into tessellations. So with these grids and some more of these simple projects is Tessellation Foundations, my free course where you can get instruction on how to fold all of the types of grid. So in there, I'm in the process of updating the videos. They should be fully updated in the next week or so. And the new videos have all of my best practices for precision, all of the ways to fold triangle grids on different shapes. So hexagon, square, 2 ways on a rectangle, how to fold thirds on any of these grids, how to fold fifths, general odd divisions, the math behind all of the divisions that we do. And I'm seeing in the chat, it's possible to buy the Skytone, the bone folder from anywhere in the world. I do charge extra shipping outside of the US. And keep your ears open for some special news about how to get Skytone from me in Europe in the fall. It's not quite public news yet, but there will be an announcement coming soon. So now we have our 8 grid divisions, and I'm going to flip to the mountain side of our paper, and I'm going to get out some pens. So I do recommend drawing on your paper the first time that you fold this. And what I'm going to mark is a zigzag. So first thing first, I have my edge parallel grid divisions oriented vertically. And now I'm drawing a zigzag on grid lines all the way across, where I'm going 1 and 1 and 1 and 1. And I'm going to go down a grid division and draw that same zigzag in blue. And actually I'm going to remember to dash my blue line. So when I'm drawing crease patterns for tessellations, I use solid red lines for mountain folds and dashed blue lines for valley folds. And in this corrugation, these zigzags are going to alternate across the page or the paper. And these are not all of the folds that we're going to add in the paper, but they're the ones that are going to be most useful in figuring out exactly what's going on. Okay, so if let's say we take this mountain squiggle and this valley squiggle, and we go and try and fold them, then I'm going to end up with an additional, so notice how I'm letting these lines come up and I'm letting the verticals between them become mountains or valleys as needed. So yeah, you don't have to keep holding it in the same orientation when you start folding. Actually, holding those edge parallel lines horizontally is easier to grasp with two hands. And I can work my way across. And one of the things that we'll notice here is that each of these turning points is actually a three-way intersection of that fold type. These valleys down below, they're also three-way intersections. We're working our way across, and it's effectively making an accordion with an offset. And so then from there, I can go further out to the next set of lines. And now when I fold that next set of lines, all of the grid lines that had been valley are going to change to mountain. All of the ones that were mountain are going to change to valley. And so we switch our accordion as we add a new set of folds. And then we can do that again with the next line of folds. And notice as I do this, I'm making sure to pop these points out and then let the valleys run between them. This is to prevent tearing at the edge of the paper. And I can do the same thing on the opposite side. And here again, actually, it's useful to pop those mountains up and pop the valleys down as I work my way across. And then I also find it useful to squeeze everything down flat to make sure that everything's in the right place before I add the next line of folds. So this pattern is commonly called Miura-Ori in the corrugation literature, or in engineering literature. And I can extend the pattern on these edges here. It's just little tucks and corner bits going down. It's commonly called Miura-Ori in the engineering literature because it was used for deployable solar panels in space by the Japanese Space Agency, and the engineer who worked on that was named Miura. But it's a pattern that's been known for centuries. I found out recently from a origami historian, yes, there do exist origami historians, his name is Joan Salas, that this pattern was first published under the name of herringbone when, like, in 1628. So there was a German guy publishing a book in Italy, and this pattern was in there. This pattern is well known in the fashion industry as well, because you can take two copies of this pattern folded in a heavy paper, like a cardstock almost, and sandwich a layer of fabric between them. So if you have two copies of this, you put fabric between, you press them together, and then you press it all up and then steam it. This is a technique called plissure. And I'll go ahead and type the name of the origami historian in the chat. Joan Salas. And so we're able to get this effect in fabric without folding the fabric, because fabric doesn't hold folds well. But if you steam it, then it can hold the shape. So some other properties that are really cool with this tessellation And I'm using tessellation and corrugation a little bit interchangeably. Tessellation is the broader group, where it covers all patterns that repeat infinitely. And this could repeat as much as you want if you have enough material for it. This is specifically a corrugation, which means that you can see all the parts of it. There's nothing hidden, and that usually comes with this squishy property as well. So some of the engineering properties of this corrugation are that when you pull it in one direction, it expands in the other direction. And that is not something that we usually see with materials. Usually materials, if you pull them in one direction, they'll shrink in the other direction. And there is a technical term for this. It's called the Poisson ratio. And so this corrugation, the Miura-Ori corrugation, or herringbone corrugation, has a negative Poisson ratio. It is also rigidly foldable, which is super useful for engineering applications, which means that if I have this made out of some material that is stiff, that won't flex in the panels, like solar panels, like metal, like all of these different options, like even hard plastic, then I can still, if I have hinges and connections at the edges, I can still make this fold. And along with that, it has 1 degree of freedom. And so when you have rigid material and you pull 2 points further apart, then all of the folds actuate in the same way. So if I were to have this folded up for my solar panel, and I have this bit on a rail, and I pull it apart, that is going to pull apart the whole panel. But because I'm using paper for this example, it doesn't behave in quite the same way because it's more flexible. And then you can have a lot of variations in this pattern. Like you can take this and make like a single surface out of it. You can make a tube going around. You can have different angles. So I could take this and pull and change the fold angle in part of it. And now when I unfold, it's not flat anymore. It's creating this arch. And so that is, you can see, moving away from those valley fold lines. There's really any number of angles. So I can do that again on that valley and on this valley as well. And now that arch is even more pronounced. And so you can create these deployable structures. This pattern has been used like in a lot of different engineering papers. It's starting to be used in real life too. You can replace all of these sharp folds with curves as well. And you can go and, if I remember correctly, this corrugation is one of the sample patterns in Origami Simulator, which I'll make sure to drop a link to in the chat, or in the video description after we're done. And there you can play with it, folding and unfolding, and there's just so many different variations that you can make with this idea of we're going to have a zigzag of folds, and we're going to match it with a zigzag of the opposite kind of fold, so mountain and valley. And those can be squiggles instead of zigzags. Those can be at different angles. You can play with this grid, and let's say you want to change whether certain folds are mountains versus valleys. You're free to do that. You can change a set of those valleys to mountains and mountains to valleys. And now you have a slightly different corrugation that you can still get to lay flat. And this I've mangled a bit and brought some of the other folds off of grid lines, so it's not going to be necessarily perfect anymore. But you can really play with this and have fun and see what different shapes you want to make out of a single sheet of paper. And working from the triangle grid can really help you get started because it constrains the variability, and then you can make more binary choices where if you were working from a completely blank sheet of paper, you might be a little overwhelmed at all the options. So I encourage you to go and explore this herringbone corrugation, the Miura-Ori corrugation, and do some searches on the internet. See where else this has been used. So that's all for this video. Happy folding, and see you next time.